This is a video key for the Chemistry 111 quiz given on September 2nd, 2016, specifically focusing on problem number 2. The problem asks you to determine the volume of water delivered by a pipette at a specific temperature. The temperature is only important in this water in that the density of water varies by temperature, and so the temperature is given so that you know when that density is true. Notice the density is reported to more sig figs than we normally think of for water. Normally we just say the density of water is 1 gram per mil. This has 4 sig figs instead of that 1. There are 2 strategies for doing this problem. The first is to use the formula for density to solve for the volume of water. The formula is that the density equals the mass divided by the volume. You are given density and mass and asked to solve for the volume. The first step is to rearrange the equation so that volume is on the top and density is not by itself. So if we multiply both sides by volume, and divide both by density, now we get volume on one side by itself and mass and density on the other side. Now we can simply plug our numbers into the formula. Volume equals the mass, 49.8904 grams, divided by the density, 0.9982 grams per milliliter. Notice these 2 grams cancel out, and now we have units of 1 over milliliters, which ends up being just milliliters. So if we plug these values into a calculator, we get our answer. $49.800 milliliters. Oh, I know what I did. I looked at that number and knew it was wrong. Notice what's my error. I multiplied instead of divided. A number of you made that same error. So let's do it right. 49.8904 divided by 0.9982 equals 49.98. Now the next question is, how many significant digits should we have on this number? There are 6 significant figures in the mass. There are only 4 in the density. Since this is a division problem, we go with the 4 significant figures, which gives us an answer of 49.98 milliliters. Now you might say, oh, I didn't remember the formula for density. That's okay. You can use unit analysis. So a second strategy for doing this problem is to simply use the units. And know that I want to get volume at the end of the day, so how can I rearrange the units I have to get to volume? Notice that we have density and it has units of grams per milliliter. There's an element that has a volume measurement in it. Notice it is inverted. It is the wrong way. Notice that saying 0.09982 grams per milliliter. That is saying that equals 1 something. If I multiply both sides by milliliters, that means 1 milliliter equals 0.9982 grams of that something. And it is equally legal to now divide both sides by that gram. And since I'm doing it to both sides, this side now is 1. So I can basically flip over that ratio. Whenever you have a ratio, as long as you keep the units together with the number they came with, you can flip it over. So I want to get to volume. I now have 1 milliliter is 0.9982 grams. That's a ratio that equals 1. I need to get rid of this grams, but I'm given a number with grams, the mass that was delivered by the pipette. Notice the math setup is now essentially the same as we did in the first problem. We just only used the units to get there. And if we put the numbers in the calculator, we should get the same thing again. And again, it has 4 sig figs because the density has 4 sig figs. Did I get units of volume? Yes, I did. Notice I got the same answer both ways. A key to doing these problems is make sure you include your units. Some people ended up with units of grams squared per milliliter because they multiplied instead of divided. By keeping track of your units, you can avoid those kinds of errors.